All right, folks, we are going to be doing number 19. Assume a parcel of air is in the straight tube moves with a constant acceleration of -4 meters per second. It has I'm going to say initial velocity of 13 meters per second at that specific time at 10:05 a.m. on a certain date. What is its velocity at 10:01 a.m.? That's part A. At 10:02 a.m. and 2.5. So I'm just going to organize it this way, folks. You have an object, and this object, I'm going to model this. I'm going to have to pick a traditional color for this. Has the initial velocity at 13 meters per second, and it's slowing down at -4 meters per second square, specifically when, and I got to be a little specific here, when t equals oh boy there we go, 0 seconds. And that 0 seconds is when it is this at this specific time. So knowing this information alone, we can already set up the equation off the bat that the velocity, because that's what it's asking for, is going to be the equation. The final velocity is going to be some initial velocity, which is going to be -4 meters per second square. I'm an idiot. 13 meters per second minus 4 meters per second square times the time. That's really the equation we're going to need. So we can specify that when t equals 0, this is at 13 meters per second. When t is, like, let's say at 1 second, so that's what part A is, when t is 1 second, that means that the velocity, and all you have to do is take 13 meters per second minus 4 meters per second square, put 1 second in there, that seconds cancel off, and you'll be left with another second. So 13 minus 4 is going to be 9 meters per second. And for part B, we do the same thing at 2 seconds. When t equals 2 seconds, you can do this at the top of your head if you can. So 8 plus 2 plus 3, which is in this case the velocity here would be 5 meters per second square. So notice as time increases, the velocity gets decreased, and that's expected. And at 2.5 seconds, so that would be 13 minus 4 times a half of 5. So that would be 2, that would be a 10, that would be, so at t equals 2.5 seconds, the velocity here would be 13 minus a 10, or in this case, the velocity is going to be 3 meters per second square. And at t equals, so let me just make room here. So that's part C, and at part D, at t equals 4 seconds, yeah, 4 seconds. So notice that like at 3 seconds, it's going to go from, well, 3 seconds would be like 12. It would be 1 meters per second square. But at 4 seconds, it's going to go from, this object is going to go from a positive, it's going to change its position positively, and then it's going to slow down right between 3 and 4 seconds, and then it's going to go down to the opposite direction. So at 4 seconds, that would be -16. So this would be at negative component at 3 meters per second. And that's it. And and at part E is asking C, D, E at -1 second. So 1 second before, this object has a speed of, at -1, that would be minus a 4 plus a 4, so you'd be left with 13 meters per second plus 4 meters per second. So that would be 17 meters per second. And part EF, describe the shape of the velocity versus time graph. Well, it's really just this equation. So if you plot that equation, this is going to be the t-axis. and this is going to be the b-axis, however you want to model it. But notice that the initial velocity when t equals 0, when t is right here, is going to be 13 meters per second. It's going to have a negative slope that's going to go straight down like this. So this is going to be between 3 and 4 seconds. I hope this is starting to be very clear to you guys. And part G is, are you for or against the statement knowing that a single value of an object's velocity constitutes acceleration? Or I'm sorry. Are you for or against the statement? Are you for or against the statement? Are you for or against the statement knowing the single value of the object's constant acceleration is like knowing a whole list of values for its velocity? So look at the key word, is like. So yes, this is very true. So that's another way of saying, and keep in mind, folks, the only reason we know these velocities is because all we're given is the initial acceleration, or the acceleration and the initial velocity. If you're not given the initial velocity, then these values, then you wouldn't know what these values are. However, it does say it is like knowing a whole list of values of its velocities. So it's not like knowing the whole list, but it is like, so because it is like, I would consider that true. So I would argue for this. And I hope this is clear for you guys. Let me know what you guys think.